Let's see how we can use calculus to help us solve a question like this. So, find the acceleration at time t equals 5. We've been given a formula for the velocity. It's not a constant acceleration, as we've not been given the kind of information we need for SUVAT, and we'll see once we've differentiated, acceleration is not constant. So remember, velocity time graph, some quadratic actually looks more like this. So we've got some quadratic. We want to find the acceleration at time t equals 5. We want the gradient when t is 5. So for part A, we're going to differentiate this, dv dt. Remember, we're not writing dy dx to say we've differentiated because we are differentiating v with respect to t. So that's going to give us 6t minus 4. T was equal to 5. That tells us that the acceleration is going to be 30 minus 4, 26. We're not going to put down any units in this case as we haven't been given any in the question. So we just say the acceleration is 26. Okay, there we go. We found the gradient of the velocity. Now we need to find the displacement at t equals 4. Notice that they've given us some additional information before that. Given that at time t equals 2, the displacement is 2. Well, we'll worry about that in a second. For now, though, let's just clear that. We remember that area underneath a distance time velocity time graph is displacement. So, how do I find area? Remember, our original equation was this. I need to integrate. So if I integrate to find my displacement, I'm going to get the integral of this that will be t cubed, 3 divided by 3 goes to 1, minus 2t squared minus 2t, and now we remember I must plus c. This is of paramount importance. There may have been some initial displacement, some constant that we need to add on to this formula. We don't know what it is yet. However, we were told that at time t equals 2, the displacement is 2. So we know that the displacement is 2 when time is 2. So we can replace all of our t's with 2. Sorry about that, I was just interrupted. So we were substituting 2 in for t. Okay, so we want to find our displacement, which was 2. We need to find our plus c. So looking at this, we've got 8 minus 4. Our c will be 6. So now we have our formula. We know that s equals t cubed minus 2t squared minus 2t plus 6. I now want to find out what the displacement was at t equals 4. Substituting in t is 4 gives us s is equal to 64 minus 16 times 2, 32, minus 8 plus 6. So that's going to give us minus 2, minus 34, minus 30. Remember, this is displacement. It can be negative. It means if we imagine we're considering displacement along the x-axis, 0 is there. We would at time t equals 4, we will be somewhere over here towards the negatives. And we're done.